Number 12. If the atmosphere can support a column of mercury 760 millimeters high at sea level, what height, in millimeters, of each of the following could be supported given the relative density values cited? So A, water, whose density is approximately 1/114th that of mercury. Now, we know from reading the text that that column would be about 34 feet high, abouts. But the question wants my response in millimeters. Okay? Now, you could do a whole bunch of gobbledygook and convert 34 feet into millimeters. That's absolutely possible using the factor label method of dimensional analysis. However, I think it's going to be a lot easier to note that because the density of water is 1/14th that of mercury, the height of the water column will be 14 times that of mercury. So I will simply do that simple multiplication. And I get myself a value in millimeters of mercury. Now, I will point out that that value has two significant figures. This value has two significant figures, and so I need to report my answer with two significant figures. That's going to tell me to report 11,000 millimeters of mercury. Moving on to B, a hypothetical liquid with a density of 1.40, that's three significant figures, times that of mercury. So the density is greater than mercury, and so the column will be shorter than mercury. So I will take that 760 and divide it by 1.40. Now remember, I want to use three significant figures here. So that value right there. Okay? What am I doing? Divided by 1.4. Alright, three significant figures right there. That 8 tells me to round that up to 543 millimeters. Actually, you know what? It's not of mercury. It's just millimeters, right? It's some other liquid. My bad. So both of these are just millimeters, right? This is 11,000 millimeters of water, and this is 543 millimeters of this hypothetical liquid. So yeah, let's not write down mercury. That's it's just a little bit inappropriate.